Hey everyone, welcome back to Quick Soil Mechanics Lessons with Brian. Today, more magic with more circles. So if you haven't seen the YouTube videos about more circles, go back and look at them because they're really helpful in getting to this stage here. So here I've drawn a tau and sigma space. I've drawn a more circle, a failure envelope, and a tangent to that failure envelope coming from the center of that half circle, and that forms, of course, a 90-degree angle at the tangent line. And we can just move this around and we'll make the filler envelope steeper. We can make it steeper than that. We can make it shallower. But we always have this tangent line. We have this failure envelope that's tangent to the Moore circle, and we have a 90-degree intersection with that line coming out from the center of the circle. So here we've got sigma 1, sigma 3. Remember, sigma 1's the primary in soil mechanics. That's the vertical effective stress. Sigma 3 is the horizontal effective stress. And we've got our failure envelope on there. And since this is at failure, because it's on the failure envelope, we have tau at failure and sigma prime at failure. And of course, the effective stress friction angle. Now, if we look at a triaxial test specimen, we can see the vertical effective stress, sigma 1, and we see the horizontal, sigma 3. We see sigma and tau at failure on that failure plane, and then we have this mysterious little theta angle down here. So let's look more at that theta angle. So here we've got a vertical line drawn from the center of that circle to the failure envelope. And because of the law of similar triangles, we know that that angle there is the same as the friction angle. And of course, that's a 90-degree angle. Let's, that equates to 2 theta. So we have 2 theta is 90 degrees plus V prime. So we've just replaced those two values with 2 theta. And so then, of course, 1 theta is half of that, 45 plus V over 2. Make just a little bit of room there. And here we've got our triaxial test sample again. So that theta angle, let's see what that is in reality. So here is a triaxial shear test specimen. I'm not saying this is the best one, but this is one that I could find. I'm not sure that I agree with the sample, but let's see here. So that angle there, according to that diagram, is theta. So theta is 45 plus V over 2. So I measured this one, and it's about 60 degrees. So just going through that formula, phi prime is about 30 degrees. So, of course, this isn't how we measure the friction angle. We get that from the Moore circles. But we could, if we wanted to, get a second estimate of that friction angle. And so that's kind of a magic angle there, that theta, and how it corresponds to the friction angle. Just coming back to our triaxial test illustration, we can see that theta angle there. That's the same one. So what is that? Well, mathematically, it's an optimization problem. The soil is looking for the plane where the driving stress most exceeds the resisting stress or strength. And at 45 degrees, you have the most push. Tau is at its maximum. But at higher angles, you get less grip. So the normal stress sigma decreases, so frictional resistance decreases. At 45 plus v over 2, the angle is at a sweet spot where the decrease in frictional resistance outweighs the decrease in driving stress. So that is why we have that magic angle theta. It's the path of least resistance. And nice and simple. That was a quick one, but I think it demonstrates some important concepts. And until next time, have fun. Let me know what you think.